Welcome to this video where we are going to focus on chemical equations. So in simple definition, if you want to define what a chemical equation is, a chemical equation is defined as follows. So here I'll just say a chemical equation so that is a simple definition of a chemical equation. Okay, so a chemical equation is made up of three parts. You need to understand three mostly given parts. You have to know three parts. So here I'll say it is made up of three parts. It is made up of three parts. What are those? One, a chemical equation must have the reactants and the products. For example, if you are reacting two things, or rather if you are trying to combine two things, those things that are combining, we say they are called reactants. In a good example, if I react A plus B getting C plus D, at this point of time we are going to say these two things that are found on my left hand side, they are called reactants, and those they are called products. Okay, secondly, a chemical equation must also have states. It must also have states. What are the states we are talking about? We know every substance is given its own nation. The states we are talking about here must be: one, we can have a liquid, something which is in a form of a liquid, and this one is given by a letter L. Okay, we can also have solid. This one is given by a letter S, and aqueous, which is denoted by letter AQ. So these are the states that every reaction must have. Okay, lastly, every equation or chemical equation must be balanced. So a reaction, or rather equation, must be balanced. What is the meaning of being balanced? That simply means the total number of mass on the left hand side must be equal to the total number of mass on your right hand side. In short, the substances that you're going to have here, if they are common with those on your right hand side, they must have the same number of mass based on the subscripts or the coefficients you are going to use. So what law applies to this type of issue whereby you are trying to make everything be balanced? That law is what we call a law of conservation of energy. This time around, I think we are able to tell what this same law is trying to mean. What's the meaning of this same law? So in short, this same law is trying to tell us to say mass can neither be created nor destroyed, but only be transformed from one form to the other. Meaning that what amount of mass you are having on your left hand side must be the same mass you are going to get on your right hand side. Suppose they say a known mass for this one reacts with a known mass for that to produce two known masses. Let's say you have been given X for this one, you don't know the mass of this one that reacted with 2 grams for that to produce 4 grams and 7 grams for the other product. What can you do for you to find the total mass of this one? You must know first of all what has been produced. You add the two masses, and also you're going to add this, you equate to that, and you'll be able to make this one move to your right hand side, and finally you're going to reach on the answer for the mass of this that reacted with 2 grams given on your left hand side. Okay, so we are saying the reaction must be balanced. It has to be balanced always. It has to be balanced. So there are certain cases whereby you find that the reaction is going to have certain conditions such as temperature and pressure, including catalyst. How do you write the same conditions I'm from mentioning here? You can either write the same conditions on top, or you can put it down. If it is a catalyst, you can either write it down here or on top of the arrow. If it is temperature, you can also put it on top, just like that. The other thing is, I'm from saying that physical species must be written in brackets. These are my physical species, L, S, and that one. How do you balance the reaction? How do you balance the reaction? So for you to balance the reaction, it becomes very, very simple. Let me try to change a page here. Okay, so definitely if you've been given an equation, suppose you've been given an equation that is made up of 4 different substances, 2 reactants and 2 products. What are you supposed to do with that type of a reaction? What are you supposed to do with that type of a reaction? So I'm going to introduce a very simple method. It has to come in a form of a formula. I'm going to give you a very simple method that you can use to balance any substance or any equation that is made up of 4 different substances. My question is this. I'll just have an example here. So I'll say balance the following reaction. Balance the following reaction. How is the reaction looking like? How is the reaction looking like? So we have this 2 here. Okay, 4 plus O2 producing carbon dioxide plus water somewhere there. This is the reaction that I'm from talking about. If you check, this reaction is made up of 4 parts. It is made up of 4 parts, 2 reactants and also 2 products. Yes, quite alright. We can balance this by the use of the usual method that we normally do. First of all, how do you balance? You need to write the species, or rather the substances that are found on every side. So we are going to say C here. I'm going to write hydrogen there. I'm going to write oxygen here. I'll come to this given site. I'll say C there. I'm going to write hydrogen here. I'll also write my oxygen somewhere there. Remember, I'm trying to balance this chemical equation. I'm trying to balance this chemical equation using the usual method. Okay, so if we check, you have to start with the one which is on your left hand side. Relate. How many carbon do we have here? We have 2. So here I'll say we have 2. Okay, so how many do we have here? We have 2. I'll put 2 before carbon. All right, I come to hydrogen. How many do you have here? We have 4 of these. Okay, and this one, okay, let me just write it here. I need to put a 2 also for this one. How many do you have here? 4. For that one we have 2. So what are we going to do for us to balance with this, meaning that this has to be multiplied by what? 2. We are going to have 4 or so. So the 2 I'm from introducing, this one has to be put before that same hydrogen. You come to oxygen. How many oxygen atoms do you have? We have 2. So I'll say we have 2 on my left hand side. But if you look at your right hand side, we said here we are going to put a 2 oxygen, 2 carbon atoms. So meaning that for this one, if you put a 2 before this, definitely you are going to bring another disturbance to this carbon. You are going to bring another disturbance to that carbon. So let me do this. Say 2 here. Again, I said we are going to introduce 2 before this to balance the hydrogen with what is on your left hand side. I say 2. So meaning that this and what is on your right hand side, everything is balanced based on carbon and hydrogen. We come to oxygen. We have 2 oxygen atoms on the left hand side. But here, once I introduce 2, I'll say 2 multiplied by the 2 which is here, 2 oxygen atoms, we are going to have 4. So I'll say 4 plus 2 multiplied by 1 oxygen atom, we are going to have 6. And yet here we have 2. So what are we supposed to do for us to balance this one? Definitely, we need to introduce 3 before this, which is going to be put somewhere here, and everything is going to be said to be balanced. So this is the usual method that we normally use whenever you want to balance any substance or any chemical equation. Let me use a certain formula that we can use for us to easily understand the same stuff in a case whereby you have four things in a given equation. Okay, what method am I saying that we are going to use? So here what we should do, you just pick 4 letters. We are going to pick 4 letters. I can pick something like this. I'll say this entire thing which is here, I'll label it as A. I'll come to this one, I'll label it as B. To that one, I'll label it as C. And finally this one, I'll label it as D. I want to give you a simple formula that you can be using for you to balance these reactions, for you to easily balance these reactions. Okay, how does that formula go? So we are going to fully understand to say, here you start with carbon. How many carbons do we have? Then you are going to relate to what you have on your products. Suppose we have a carbon here, we have carbon there. What we are going to do, we are going to be using the coefficient, or rather these letters, with reference to the number of carbon you have. If here we had carbon again, I'll add with the same number of carbon, multiplying with B. So since here we have 2 carbon, meaning that it is found on A, I'll say 2A. Do we have carbon here? No. You come on this part, I'll say it is found after the equal sign. So this is going to be, how many carbons do we have? We have 1 carbon. It is found on C, I'll say C. That is the first equation. Okay, I'll come to hydrogen. How many hydrogen do you have here? Do we have hydrogen there? Do we have hydrogen here? And do we have hydrogen there? You relate it like that. If we have hydrogen here, we are going to add the number of hydrogen we have based on C plus the number of hydrogen we have based on D. How many do we have? We have 4 hydrogen atoms. Sorry, it is found on A. I'll say A. Here there is no hydrogen, but it is found on D. I'll say, how many hydrogen do you have? We have 2D. So this has to be the second equation. If you want, you can even reduce this by cancelling these, and you have 2A, which is going to be equal to D. This still stands to be your third equation. I mean your second. Okay, let me put it as the third equation. Okay, let me just remove this. Okay, so we come to the other part now. This part is meant for oxygen. We are moving now to oxygen. How many oxygen atoms do you have? We have 2 oxygen atoms. On the part of the reactants, it is found on what? On B. So I'll say 2B equal to, I'll come here. Do we have oxygen on this one? Yes, we have 2C. I'll come to this one. How many oxygen do you have? We have 1. So I'll say D. Now we are going to have 3 equations. So always, whenever you come here, for you to find the values of the other, always, whatever you're going to have here, you say let A be equal to what? 1. Always, you have to say let A be equal to 1. Meaning that if you put 1 here, we are going to have C, which is going to be equal to 2 multiplied by 1. The value of C has to be equal to 2. You come on D, you say 2 multiplied by 1 again, it has to be equal to D, meaning that even the value of D has to be what? Has to be equal to 2. If we come on this given part, we have the value of C, we have the value of D. What are we going to do? We are going to find the value of B. So I'll say 2B must be equal to 2. The value of C is given as 2 plus the value of D is what? 2. You can do this. You cancel this, you cancel that, you divide that. We are going to have B, which is going to be equal to, we have 2 here remaining. We are going to have 1 there. 1 and B is going to be equal to 3. So these letters that we are from that we had here, they are called coefficients. They are going to be called coefficients. And what are you supposed to do if you reach at this given point? What are you supposed to do whenever you reach at this given point? It is very, very simple. It becomes very, very simple whenever you reach at this given point. Why? Because what you are going to do, you just, what is the value of A? We said it has to be 1. You come to the value of B. I'm from finding that the value of B is what? 3. The value of C, we found that the value of C is 2. The value of D has to be what? Has to be 2 also. So no matter how many quantities you can have or how many atoms you can have on your left hand side, if we had such a thing on this part, I would have followed the same procedure. That is the best way for you to balance a chemical equation. So whenever they ask you to say what is the number of mass that is going to react with maybe a given mass to produce the masses for this, the process to use or the law to use is what we call the law of conservation of energy and matter. The law of conservation of energy and matter. So this is what you should be doing whenever you want to balance a reaction. Thank you very much. I'll drop another example so that you can try to solve on your own. You try to balance using the same method. Good day.